Hello there. A while ago I bought this really cool multifunctional radio called the Raddy RF320 or HanRongDa HRD-A320. Actually, it's available under a number of different names, but it's basically the same radio. And I've had a lot of fun with it. It sounds great, it's powerful, it's got a Bluetooth player, multi-band radio. I like to listen to a bit of shortwave on it. It's got Bluetooth, loads of stuff. It can record audio as well. And it's compact, generally a good little radio to carry around. And I've used it more than I expected actually, it's pretty good. So one of the things it didn't have, and you can have a look at the review and teardown that I did recently, I'll put a link in the comments, is it didn't have an antenna socket on the top for an external antenna, which if you're listening to shortwave, it's a really good thing to have. So you can put your long wire antenna in it, or a Magloop antenna. Oh, Magloop antennas, I got to talk to you about that a bit later, and I'll show you how to make one. They make a real difference to your reception. And I've hummed and hawed about it and didn't really get round to it, but then the fine tuning knob broke on the side. So I got a dodgy knob. You can turn it, but it doesn't do anything. So I thought, well, let's repair it, and while I'm doing that at the same time I can put in this antenna jack, and while I'm at it I can also try and make a mod to the amplifier and increase the output power. If you saw my teardown video, you know what I'm talking about there. And also improved a bit of the wiring inside. So hang around and I'll take you through the mods that I'm going to do step by step. Hope you enjoy. And as usual, I would like to give a huge thank you to the sponsor of this video, PCBWay. They are my PCB manufacturer of choice and have a very easy to use ordering service. All you need to do is simply give the basic parameters of your PCB on their website and they can give you an instant quote. The service is incredibly fast and their prices are always very low. In addition to PCB prototypes, they also offer a full PCB assembly service. Their range of services also includes the manufacture of flex, rigid and HDI PCBs, and in addition they also provide services for CNC machining and 3D printing. And makers will appreciate PCBWay Plus, which provides access to a whole community of makers sharing their projects, and they even have a shop for maker tools and modules. For more information, go to PCBWay.com. I've included a link in the description. Now, as I've already done a disassembly and reassembly in some detail in my teardown video, I won't go over a lot of it here. So if you want some more information, do take a look at that video. Now, one thing to be careful of is when you do open this case, there's some very fine wires connecting the AM ferrite antenna to the PCB. So when you open it up, you have to be very careful. Also, you'll note that you have to take off the sticky rubber feet and remove or loosen the sticky pads around the audio and ear input jacks and the SD card input slot. You need to loosen the glue around those before you can open this up. Okay, so you need to desolder the antenna cables. You've got the combined FM and shortwave antenna there, and then you've got the two very fine cables going to the ferrite AM antenna. I extended one of them, you can see there previously. One of them actually snapped off again when I was removing it. I'll have to extend the other one as well. Okay, that's pretty much what you need to do to kind of spread the thing open. So the first thing I'm going to do is show you the point of failure, or at least we're going to try and find it, that caused my dodgy knob. It's the fine tuning one on the side. Just one day I came to it and then I was spinning it and it was just freewheeling and not doing anything. So here's the dodgy knob. You can see that it's got like a plastic bearing on the outside. And on the inside, I think there should be some sort of shaft which goes into a rotary encoder on the main PCB. So here you can see the rotary encoder. Let's get a bit closer. And inside is still the bit of the snapped off shaft that came from my dodgy knob. You can see that there. And that's where the shaft, you can see it's kind of like a six-sided hexagonal shape shaft. And it's completely sheared off. Now this might be a weak point. Let me know in your comments if you've got a dodgy knob. I'd love to know how common this is. Maybe it's a design issue, or maybe I damaged it a bit last time I took it apart from the teardown. I don't know. It's not going to be so easy to fix. I'm not sure what to do about that. Well, it's going to be temporary anyway. I'll see if I can get a new knob. If anybody knows where I can get a new knob, please let me know in the comments. And here I've taken out the knob shaft. You can see the hexagonal hole. And there's the shaft. There, can you see how small it is? It's no wonder it snapped off. And that's what the shaft looked like attached to the knob. That's not going to be easy, even for a temporary fix. But what I found was this hex bit, 1.5 mil, is a perfect fit. And it should make my knob shaft stronger than it was in the original. I thought I could, it's almost a fit for that hole on the knob. Just expand it a bit with a drill bit, and then I should be able to push it all the way through. Problem is, it's a bit too long. I'm gonna have to cut it off about there where the one is, I reckon. That should be good. Here we go. Now I drilled the hole just a bit smaller than the new shaft, and I'm going to heat it up and then push the shaft all the way into the knob. There we are. Refitted, and it's perfect. I think this knob's probably better than the original, but I still want to get a new one. So let me know if you know where to get one. I just need to make the shaft black to fit in a bit better. And there we have it. One new fine-tuning knob. Well, not new, as good as. And now the best bit, to put an antenna jack. So if you remember from the teardown video, we got this AKC 6958 radio chip with audio output and control status connections to the microcontroller. We've got an AM ferrite antenna connection, or two connections. We've got shortwave and FM antenna inputs connected together, and they go to the internal telescopic antenna. Then we got like a bipolar Zener transient suppressor. Pretty much it for the front end. Then to allow us to insert an external antenna, we have the 3.5mm socket. You can get stereo on a mono one. This is actually a mono one. That's all you need for external antennas. So you have a static part which is connected to the original antenna. Then you have a moving part which is connected to the antenna input, the original antenna input. So you put your jack in, or your 3.5mm socket, and that pushes the movable part up, disconnecting the internal antenna. And then that external antenna can then connect to the input of the radio device. Then you have the ground connection, which will then go to the ground at a point which is close to the radio IC. And we use a shielded coax for that. So I know this is very familiar to you, I'm sure. Let's just have a look at the connections. So you got ground or common, then you got two connections for left and right for stereo. But we of course just can use the tip for the antenna connection and the ground. So we're not going to use that connection in the middle. That's why you need a mono one. Okay, so that's the antenna bit there at the end. So if we have a look at the jack that I'm going to use, there's many different types, by the way, but I've showed this one because it's easy to see all the internals. Some are kind of closed in a kind of little enclosure. Let's have a look. So you can see that, let's get a bit closer, that bit there is the fixed part, so that will connect to the internal telescopic antenna, and then that movable part is the curved bit, which moves up when you put the jack in, and that is going to basically connect to the antenna connected on the input. And then here you can see you got the ground or common connection, and that makes up the 3 solder tags. Now you might think, well, this one's got 3 solder tags, this will do, but actually it's not switching, it's just got a ground and left and right. It's a stereo jack. And that's why you've got 3 connections. It's not a mono jack with a built-in switch. It's not what you want, so be careful of the type that you select. So let's just have a look at how this works. So you push in the jack, and if you look carefully, when inserted, you can see the curved bit has moved and disconnected from the fixed part, which doesn't move, and that's what will allow us to disconnect the internal antenna when we connect to the external. That's important for reducing noise from the internal antenna. Why didn't I use an SMA jack, some of you might ask, like you see on some radios? It's because it doesn't have a switch built into it. You can insert an SMA plug and get it to automatically disconnect. You'd have to add the additional switch or something, so it's easy. And a lot of cheap radios use the 3.5mm jack. So I've had a look around to try and find out where would be the best place, and marked it. I'll share the dimensions with you so you can see where I've put it a bit later. So first of all, I've put masking tape to prevent scratches in case I slip, and use it for marking where I want to put the jack. And then for this particular jack, I need a 6mm drill bit. You best check the jack that you've got to make sure it's the same size. Should be about 6mm. So start off with a pilot hole, 3mm. That's all right, just where I want it. And finish off with 6mm. That's perfect. Just do a quick test fit. You'll note that You may want to get the same type as I chose in the open frame one. At least you'll know it fits. Not to say that others won't, but why take the risk? And it's good you can actually see what's going on inside these things, so they're easier to wire up. I won't do it all the way up at the moment. I'm going to wire it up properly before I fit it. Okay, it looks good. Now, really, you should just close the thing up and just check that there's no interference of anything else inside. I just quickly put it together. It's very tricky getting this thing together. Sometimes the light on the side stops it going, but that looks good. Okay, let's get the wiring done. Much easier to do this before you assemble it. Now I'm using some very thin, flexible coax here. I think it's 50 ohm cable, not that it really matters that much. It's only going to a short distance. Why have I bothered to use coax? Well, if I'm using an external antenna which is shielded, I want to take that shielded cable as close to the radio IC as possible to minimize interference, not only from outside but also the internal digital circuits inside the radio. It's always good to try and reduce noise as much as you can. Now let's just do a check. And now I see a potential problem here. I'm not happy with that. Can you see that the tip, which is carrying the aerial signal, could potentially touch the common or ground connection? Because where I strip back the insulation, the shield on this cable is exposed. I'm going to put some heat shrink on that and do that again. So you might want to check this when you do it. You might do a better job than me, but just do a quick test by plugging it in. Okay, that's better. I'm happy with that. Okay, then we need to provide some sort of area where the ground connection on that shielded cable can connect to on the PCB. Now we want it to be as close to the radio IC and the FM or shortwave antenna connection on the PCB as possible. I think it's about as close as I can reasonably get it. So I'm just using a file here to scratch off the solder mask, and then once I've got a patch big enough to solder that wire, I just tin it, but I won't actually solder that wire on until I do the last assembly. I just prepare it for now. Now, if you used a similar connector to myself, then you can use these pictures to help guide you on where to put the hole. Now, with reference to my teardown video, this amplifier chip is unique as it produces its own power for boost pin 1 controls that power or that voltage internally. If we break that connection to change the voltage from 0 to 3.3 via this resistor, which we can take from a shift register, the 74HC595, we can increase the internal boost voltage and therefore the output power. So here I've pre-prepared a 270 ohm resistor with fine wires attached to it, and I'm going to get my 3.3 volt reference from the VCC pin or pin 16 off of this 74HC595 shift register. There we are. Is that done? Let's check it. Yes, okay. Now I'm not going to connect that resistor yet, so the chip amplifier strip is still in its original mode. So I've got the output connected to two 8 ohm resistors to create 4 ohm load, and then I'm measuring the RMS voltage across that load using this fluke meter. And then I've got a signal generator, a function generator, connected via Bluetooth. And then I've got this Finercy mini scope, which is being used to monitor the output waveform. We just switch it on, and there you can see a kind of square wave. It's noisy because it's class D. In fact, the reason I'm using this scope is because it inherently filters out a lot of stuff. It's got a low bandwidth. If you try and use a normal scope, you can't see hardly anything. You can't make out a sine wave. So currently we got around 4.2 volts RMS on the output. That's kind of maximum without very bad distortion. And then I'm going to measure the boost voltage on the chip, which I think is pin 6 and ground. And you can see on the Finercy multimeter there 6.3 volts. So changing the mode of the internal boost circuit by changing pin 1 on the amplifier chip from 0 volts to 3.3 volts, and you can see I've made the connection there if you look closely. I've done it by heating up pin 1 and lifting it up off the board to disconnect it, and then I've connected that wire which goes to 3.3 volts via the 270 ohm resistor. I just connected it temporarily for the moment. I'll secure it later if this circuit works. So here it is connected, and let's try again. So same output from the function generator app. You can see the sine wave there, and I've now got 4.62 volts. So it's higher than we originally had, so that's looking good, but not as high as I thought. Just measured the internal voltage, and we've got 6.8 volts, so that's higher than the original 6.3 we had, but according to the specs it's 7.1 volts when I changed the mode. Well, perhaps that was under optimal conditions, but still that's more output, so that's good. But how much? Okay, so before the mod, the V boost voltage was 6.3 volts, and that gave us an output of 4.22 volts RMS, which is 4.45 watts. And after the mod, 6.8 volts internal boost voltage, giving us 4.62 volts RMS output. Across 4 ohms is 5.3 watts. So less than a watt, but at least it's higher. No, look what happened. My camera mount failed, and the camera fell on my Finercy oscilloscope multimeter and smashed it. Damn it. Well, if anybody knows where to get a replacement screen cover, do let me know. Maybe that was another test. Would that happen on a Fluke or a Unity? So I secured those very fine wires which go to the amplifier chip with ultraviolet cured resin, and then And here's another mod I did. I changed those really thin speaker wires with thicker ones. And then you can see the resin that I used and the resistor linking the 3.3 volts to the amplifier chip. I just put it back together. I had to make another slot in the side of that mini speaker cabinet to accommodate the thicker wires for the speaker, but the ones that were too thin before. And finally connecting up the internal telescopic antenna to that fixed connection on the 3.5mm jack, and finally assembling it. Careful not to scratch the case. Just make sure that original antenna cable doesn't get in the way of anything. A bit of cable management. Then after the other connections are made, the battery, etc., solder that new coaxial cable, antenna cable, into place. Remember to put the screen on that new ground connection that we put in, and the center to the original telescopic antenna input connection on the PCB. And carefully put it together, make sure none of the wires are being trapped by anything. And Bob's your uncle, there we are. I'm pleased with that. Oh, light comes through that hole as well, through the antenna jack. That's good to be able to locate it in the dark. That's coming from that LED at the back. Oh, that's really cool. I'm very pleased with that. Now, in conclusion on the changes, for the amplifier mod, there's no point in me trying to show you on this video because you won't be able to appreciate any changes by listening. But I think it does sound more powerful a little bit, but it might be a bit of placebo there, I'm not sure. But is it worth it? No, I don't think so. I mean, it's quite risky making those modifications, especially if you're not used to working with surface mount devices. Lifting that pin 1 on the amplifier chip, and there's a lot of really small components around it. It'd be easy to tear a track, and I don't think the benefits from the risk you take are just worth it, to be honest. Now, the addition of the external antenna input, on the other hand, I think is just fantastic. I'm going to show you some tests now, let you hear for yourself. What you'll see me do is I'll tune it to a really weak station, and then what I would do, I'll let you hear what it's like through the original antenna. And then I will touch that antenna with a long wire antenna, an external one, which is about 12 feet, about 4 meters in length, which is mounted inside my apartment. I'm 6 floors up in an apartment in Singapore. And then I will plug it in, and you'll see that you'll get some sense that the station's there, but not much. But then the big impact comes when I plug a Magloop antenna in. Now, a Magloop antenna is very simple for just receiving use. It's basically a circular loop of coaxial cable with a split in one end, and a type of noise rejecting coupling coil at the other end, which you can wind yourself very easily. You can buy them online really cheap, for receiving, that is. They can be less than $40. Or you can make one really easily out of parts you can find lying around your house pretty much, and that's what I'll show you in the next video. So do subscribe and hit that notification button so you can find out when I release that. So as you can see, this one's made out of a children's spinning hoop and a bit of coax, about 70 centimeters across. So that's enough me going on. Have a listen and see what you think. So the external long wire antenna, the 4-meter one, is just strung along some curtain rails, and the homemade Magloop antenna is just propped against a wall near a window. So here I am touching the external antenna on the telescopic and now inserting it. You can just hear a station. Do it again. Now I'll plug in the Magloop antenna. Now try different station again with the long wire antenna. Just hear a station. Try the Magloop. What an incredible difference. And the Magloop antenna is really good at rejecting noise as well from lights and computers and things around your home. I found a lot of stations available when using this Magloop antenna, which I never have heard on this radio before. Well, there you have it. So I think the antenna jack is just awesome. And if you don't want to use it for a Magloop antenna, of course you can use it for a long wire. But I can't really test that properly because I live in an apartment. But you know, if you've got a garden or something, then of course you can use a conventional long wire antenna for that if you want to. It's just, I think if you live in an apartment, or you know, you don't want to have a big antenna outside, and you can use a Magloop with this input jack, then I just think it just opens up a whole new world of listening for this radio. And if you know where to get a new knob, let me know. Or do you have a dodgy knob yourself? If you do, let me know in the comments. I'd love to know how often these things are breaking. And also, if you know where to get a replacement screen for my Finersi meter oscilloscope, I'd like that too. But anyway, if you found this interesting or useful, please do subscribe. It does help me a lot. And I'd love to hear your comments, so please keep those comments coming in. and stick around and look out for my next video where I'll show you how to make a Magloop antenna from the bits lying around your house. You don't need a cat, by the way, just in case you were wondering. So thank you very much for watching. Take care, and I'll see you again soon.